Working with radical exponents. I'm Anil Kumar, and now let us further explore such equations. The question here is very interesting. It says, can we get two solutions for the following equations? Explain. So let us figure out whether we'll get one solution, two solution, or no solution for a given equation. We have two examples here. The first one is x to the power of 2 over 3 equals to 9. Then we have x to the power of minus 2 over 3 equals to 16. Let me add one more here. X to the power of 2 over 3 equals to minus 1. Okay. So we have now three equations. Now we'll figure out how many solutions can these equations have. Let's begin with the very first one. X to the power of 2 over 3 equals to 9. Well, what do you think? How many solutions can you get for this equation? 1, 2, or 0? How about this? And how about that? Okay. Since we have x squared, we actually expect two solutions for this equation. Remember, square of any number is always positive. 9 is positive. So we do expect two solutions. In this case, here we have minus 2. Minus means reciprocal, right? But 16 is positive. So we expect two solutions. In this particular case, think how many solutions do we expect? Well, we'll get back to this later. Let's begin with the first one, which is x to the power of 2 over 3 equals to 9. Now to find the number of solutions, what we can do is solve it and then check for ourselves. Okay. So x to the power of 2 over 3, I could write this as x to the power of 1 over 3 by taking square root on both sides, right? Equals to square root of 9, right? So what I've done at this stage is I've taken square root on both sides. So do square root both sides. When I say square roots both sides, it's kind of like this, to the power of half, and this is also to the power of half, right? That is square root. So when you multiply half with 2 over 3, you are left with 1 over 3. That's another way of looking at it. Now remember one thing, whenever you do square root, you should write plus and minus. That is kind of very important. That leads to two solutions, right? So we get here x to the power of 1 over 3 equals to plus and minus square root of 9 is 3. So what is x now? So x could be equal to cube of this, right? So next step to solve this is to write cube, right? Cube both sides. Right? So that is to say now I'm doing cube, right? Cube on both sides. So when you do cube of plus 3, what do you get? So there are two possibilities. One is we have 3 cube, and the other one is minus 3 cube, right? So 3 cube is 27, so we have 27, and minus 3 cube is minus 27. Do you see that? And therefore we do have two solutions. We can write down our answers as 27 and minus 27, or plus minus 27. Correct? So that is how you could actually solve such equations, and you should get two solutions, right? Now let's do the next one, which involves negative exponents, right? I hope you remember, negative exponents means what? That means I could write this as 1 over x to the power of 2 over 3. Negative results into reciprocal, right? So this results into reciprocal. And then the equation is 1 over x to the power of 2 over 3 is equals to 16. Now in this case, in last time we squared first, right? Square root, right? This time we'll cube. So this time let us cube both sides. So different strategy this time. We'll first cube and then square root. So if you cube both sides, what do you get? You get 1 over x whole square equals to 16 cube, right? So let me use calculator to find cube of 16. So we have 16 cube, which is equal to 4096. Okay, so that is equal to 4096. Now 1 over x square is 4096. So what is 1 over x equals to? We have to square root both sides, correct? So we'll square root 4096. And whenever we square root, we have to write plus and minus, correct? So what do we get? So let us do square root of 4096. We get 64. So that is equal to, let me write down here, equals to 64 with plus and minus sign, right? So two answers. So x is equal to how much? X is equals to reciprocal of that. You can think about cross multiplication. 1 over 64. Do you see that? So we again get two solutions. So whenever you have square, it could be in any form, but that square results into two solutions. So we do have two solutions here also, and our answer is plus minus 1 over 64. Now here is the third question which I introduced, and there was a reason for that. X to the power of 2 over 3 equals to minus 1. So if I write any number here, then what will happen? I'll never get a negative answer, will I? Let me check. Let us try 1, right? So 1 to the power of, plus 1 to the power of 2 over 3, we know will be 1. How about minus 1 to the power of 2 over 3? Minus 1 to the power of 2 over 3. First, let us check with calculator. So within brackets, minus 1 exponent within brackets 2 divided by 3 bracket close equals to. It gives me plus 1. It does not give me minus 1. Do you see that? So always when there is 2 there on the top, whenever we square, we get a positive number, right? So there, in this case, there is indeed no solution, right? So here we have no solution, correct? We can actually show it. Let me share with you how to find whether this is no solution or not. So what we will do is, we'll again solve as we did these two. We have x to the power of 2 over 3 equals to minus 1. Let us cube first. Then we have x square equals to minus 1 cube. Cube of minus 1 is minus 1. And now to get x, we'll square root. Whenever you square root, you have to write plus and minus. Plus and minus square root of minus 1. Well, that is not a real number, right? It is imaginary number. So when we are working on real numbers, there is no solution. We'll say no solution, right? Remember, we are only working with real numbers. Okay. Soon we will take up complex numbers, and then we'll have a solution to this. Okay. For the time being, we'll consider this equation in the domain of real numbers as the one without any solution. So what you notice here, that there are times when radical exponents may lead to two solutions or no solution. That is kind of important to understand. I'm Anil Kumar. You can subscribe and learn a lot. Thank you and all the best.